Good morning, learners. Welcome to another interesting science lesson. On your previous discussion, you've learned that the lithospheric plates are moving slowly in different directions. These plates are classified into three types of plate boundary, namely divergent plate boundary, transform plate boundary, and convergent plate boundaries. Along this plate boundary, different geologic processes and features occurs. Examples: Alright, so along these plate boundaries, different geologic features and processes occurs. Examples of this are volcanoes, mountain ranges, and earthquakes. Now, remember, but what do you think will happen, or what do you think will be the geologic process that will occur at a specific type of plate boundary? What do you think will happen if two lithospheric plates collide? That are what we are going to find out on today's discussion. At the end of my discussion, you are expected to first, you are expected to explain what happens when oceanic and continental crust collide, identify the landforms associated with continental and oceanic convergence, explain what happens when two oceanic crusts collide, then you are going to identify the landforms associated with oceanic plate convergence, explain what happens when continental plate collides, and identify the landforms associated with continental plate convergence. Now remember that there are two types of crust, or two types of lithospheric plate. We have the continental crust and the oceanic crust. Continental crust is thicker but is less dense, while the oceanic crust is thinner but is denser compared with the continental crust. Now, this concept is important in understanding the different processes that occurs along plate boundaries. Take note, students, that the process, features, and events that will occur along plate boundaries will depend on the type of lithospheric plate involves. Now, in the case of convergent plate boundary, we have three types of collision. First is the collision between oceanic and continental crust. Second is the collision between oceanic and oceanic crust. And third is the collision between two continental crusts. Now, let us start with the first type of collision. Now, this diagram shows the collision between a continental crust and an oceanic crust. I'll be giving you 30 seconds to study the diagram. Observe the process. Observe what are the landforms that is formed on this type of plate boundary. Alright, so again, this diagram shows the collision between continental crust and oceanic crust. Now, what can you observe on the oceanic crust? what is happening on the oceanic crust. Alright, you are correct. As you can see on the diagram, the oceanic crust is bending towards the mantle. Now, why do you think this is happening? Why do you think that the oceanic crust is bending towards the mantle? Alright, you are correct. Remember that oceanic crust is denser compared with the continental crust. Now, in the process of collision of plate, the denser crust will be the one that will subduct towards the mantle. Now, this process is what we call subduction. Subduction process is the tectonic process that occurs along convergent plate at which a slab of continental plate descends or bends towards the mantle. Again, this process is what we call subduction. Now, this part is the subduction zone. It is where the continental plate is subducting. Okay? Now, what do you think will happen to the leading edge of the oceanic crust rather as it bends towards the mantle? What do you think will happen to the rocks of the oceanic crust? Alright, you are correct. Remember that as we go down to the layers of the earth, the temperature is increasing. Now, the increase in temperature causes the rocks to melt, forming magma. And the addition of volatile materials, such as water, makes this magma less dense. Thus, it rises up towards the continental crust. And what do you think will happen to this part of the continental crust? What do you think will occur here? Alright, so you are correct. There will be formation of volcanoes and there will be possible volcanic eruption. So this chain of volcanoes are what we call volcanic arc. So when we say volcanic arc, these are curving chain of active volcanoes formed above the subduction zone. Alright? Now, a specific example of volcanic arc is the Cascade volcano. Cascade volcanoes. Cascade volcanoes are found at the North American plate. These cascade volcanoes are formed due to the collision of the Pacific plate, an oceanic crust, and a continental crust, North American plate. So this cascade volcanoes extends from the British Columbia up to Washington, Oregon, and northern part of California. So it is composed of 20 major active volcanoes. And you see here the volcanic activity. You see on the diagram the volcanic activity of the volcanoes of the cascade volcanoes. Alright? So aside from volcanic arc, aside from volcanoes, what other geologic features do you think will occur or will be formed because of this collision? Alright, so you are correct. So you can see there a trench. So a trench are long, narrow depression on the seafloor that forms at the boundary of tectonic plates, where one plate subduct or bends beneath another plate. So here is the trench that is formed because of the collision of continental and oceanic crust. Now, because of the constant dipping of the oceanic crust beneath the continental crust, it produces earthquake. Okay? And here on this example, you can see there the Philippine Trench. So the Philippine Trench here is produced due to the collision of the Philippine Sea Plate with the Philippine Archipelago. So Philippine Trench is the second deepest trench in the world. Now, as the dipping of the Philippine Sea Plate continues, it induces frequent earthquakes that we are experiencing in the country. Now, one example of an earthquake produced due to the collision of continental and oceanic crust is the magnitude 9 earthquake that struck Japan in March 11, 2011. The epicenter of this earthquake was recorded 130 kilometers west of Sendai, Japan, and the focus occurred 30 kilometers depth below the ocean floor of the Pacific Ocean. So the event during this earthquake started with a powerful earthquake that caused widespread damage on land. This powerful oceanic earthquake, induces the production of tsunami. When we say tsunami, these are giant waves caused by earthquake or volcanic eruption under the sea. So this under the sea earthquake induces the production of tsunami that devastated many coastal areas in Japan. So you will see here on the picture, how devastated Japan during the tsunami on March 11, 2011. Alright, so let us now go with the second type of convergence of plate. This is the convergence between two oceanic crusts. Now, I'll be giving you another 30 seconds to observe the diagram. Okay, so again, this diagram shows the collision between two oceanic crusts. Now take a look at the oceanic crust here on this side. Do you observe subduction process here? On this type of collision, is there subduction happening on the crust? Alright, correct. So there is also subduction on this type of collision. Since there is subduction, the leading plate of the subducting crust will form magma, will melt and form magma. This magma will rise up, forming volcanic island arc on this part of oceanic crust. Now, what is volcanic island arc? Volcanic island arc are long curve of chain of volcanoes associated with intense volcanic and seismic activity. Now, you will question why oceanic plates subduct since they are two oceanic crusts colliding. There are two oceanic crusts that is colliding. Remember, the older rocks is denser. So on this example, the older oceanic crust is denser compared with the other oceanic crust. Thus, it is the one that will subduct beneath the other oceanic crust. Alright? So, did you know that the western part of the Pacific Ocean is mostly made up of volcanic arc? This includes Indonesia, Philippines, and Japan. So this part of the Pacific Ring of Fire is made up of volcanic island arc. Alright? Next, let's have continental. So, aside from volcanic arc, you will see here, trench is also formed parallel to the volcanic arc. So, because of subduction process, there is also formation of trench on this part. And because of subduction, because of grinding of crust, earthquake might also occur. And strong earthquake will also induce the occurrence of tsunami. Alright? So let's move on with the last type of plate boundary. Okay, so the last type of plate boundary is the convergence between two continental crusts. Now I'll be giving you another 30 seconds to study the diagram. Alright, so again, this diagram shows the collision between two continental crusts. Now, is there subduction? Is there subduction process on this type of convergence? Do you observe subduction process? Alright, correct. There is no subduction on this type of plate boundary. So subduction ceases. When we say subduction ceases, there will be no volcano, there will be no volcanic eruption, there will be no formation of trench on this type of collision of plate. Now, what is formed here are mountain ranges. So what are mountain ranges? Mountain ranges are group or chain of mountains that are close together. Now, how these mountain ranges are formed? Since there is no subduction, the collision between in the collision of two continental crusts, the pressure, the force is pushing upward, causing the formation of the peak of these mountains. Alright? Is there earthquake that will form or that will occur on this type of collision? Do you think there will be earthquake that will be formed? Yes, there will be earthquake that will occur on this type of collision. Right? So earthquake is also present. So one example of mountain ranges that is formed due to continental cross collision is the Himalayas mountain. So Himalayas mountain is the tallest mountain range that is found on Earth. Alright? So it is formed because of the collision of the Eurasian plate and the Indian plate. So you see Himalayas mountain here. So the collision of these two continental plates causes the formation of mountain ranges. Another example is the Andes mountain range. Andes mountain is the longest mountain range that is found on Earth. Okay? So this is also formed due to the collision of two continental crusts. Alright? So we are done describing the different processes, geologic features that occurs between or that occurs along the three types of convergent plate boundary. Now, to sum up our discussion, let us have a short activity. So you are going to identify if the geologic process, event, or feature that I am going to flash on the screen will occur on this type of plate boundary. So you're just going to hit the like react if the geologic feature or process will occur on this type of plate boundary. You are going to hit sad face if it is not. Alright? So let us start. So let us have volcanic arc. Do you think volcanic arc will be formed on this type of collision? The collision between continental and oceanic crust. So you hit like if your answer is yes, and you hit sad face if it is not. Okay? May I see your answer? So the correct answer is yes. So volcanic arc is formed in the collision of continental and oceanic crust. So you are correct. Very good, students. Let's have the second one. We have here trench. Do you think a trench will be formed on the collision of continental and oceanic crust? So hit like if your answer is yes, and sad face if no. Alright, so may I see your answer? So if you hit like react, your answer is correct because a trench is formed in the collision of continental and oceanic crust. Now let's move on with the third one. We have here mountain ranges. Do you think mountain ranges is found or will be formed when oceanic and continental crust collide? Hit like if yes, hit sad face if no. Alright? So the answer is, alright, sad face. Mountain ranges are not found at the collision of continental and oceanic crust. Right? Good job, students. Now, let's have the fourth one, subduction. Do you think subduction process is present on this type of collision? Hit like if it is yes, sad face if not. Okay. So I can see your answer. So subduction process is present at continental and oceanic cross convergence. Now the last one, earthquake. Will there be earthquake that will occur at this type of collision? Like if it is yes, and sad face if no earthquake will occur. Okay, so the correct answer is yes. So earthquake is formed, or earthquake will occur at this type of collision because of the subduction, because of the grinding of plates. Alright? Now let's move on to the second type of plate boundary. The second type of collision. The collision between the oceanic and between two oceanic crust. So let's have the first one. Mountain ranges. Do you think mountain ranges will be formed at this type of collision? Like if yes, and sad face if not. Okay, so the correct answer is no. So there is no mountain ranges that will be formed on this type of collision. Next is subduction. Do you think subduction process will occur at this type of collision? Alright, so may I see your answer? So the correct answer is yes. Subduction is present at the collision of two oceanic crust. Good job, students. Now, let's have the third one. The third one is volcanic island arc. Please click your answer. Alright, so the correct answer is thumbs up. So volcanic island arc is present at the convergence of two oceanic crusts. Next is trench. Will a trench be formed at this type of collision? Alright, so the correct answer is yes. So a trench is also formed at the collision of two oceanic crusts. And the last one, earthquake. Okay, so the correct answer is yes. The earthquake will also occur at this type of collision. Good job, students. Now let's move to the last type of convergent plate boundary, the continental and continental convergence. Okay, so first, subduction. Is it present on continental-continental convergence? It like if yes, and sad face if not. Okay, I can see your answer now. So the correct answer is sad face. There is no subduction process present at continental convergence. Right? Good job, students. Next, let's have volcanoes. Will volcanoes be formed at this type of collision? The correct answer is no. There is no volcanoes that will be formed at this type of collision. Alright? Next, let's have mountain ranges. How about mountain ranges? Will it be present at continental-continental collision? Click your answer. So the correct answer is thumbs up. So mountain ranges are present or will be formed at this type of collision. Last one. We have trench. So the correct answer for trench is sad face. So it will not be formed at the continental convergence because there is no subduction process. Alright? And the last one, earthquake. Correct answer is like. So shallow earthquake are also present at this type of collision. Okay? So good job, students. Now, I am going to open the comment sections for your question. The moderator will just choose 3 questions for me to answer. Alright? So I think the moderator already have chosen 3 questions from the comment section. So this is the first question. Question from a student of Danandana National High School. Is there a possibility that tsunami will hit the Philippines? Actually, tsunami is very rare in the country. The last record of tsunami was on March 2011. This tsunami, the record of tsunami during that time was about, the height of the tsunami was about half a meter. And although the occurrence of tsunami in the country is very rare, there is still a possibility that a tsunami will hit the country. Specifically, especially when the strong earthquake will occur at the ocean floor. Right? So let's have the next question. Are there mountain ranges in the Philippines? The answer is yes. So mountain ranges are also present in the Philippines. The longest mountain range in the Philippines is the Sierra Madre. It extends from Santa Ana, Cagayan at the north up to Quezon Province at the south. So that is how long Sierra Madre is. Okay, so if there is the presence of mountain ranges, therefore there is also collision of continental plate in the country, in the Philippines. Okay, so let's have the third and the last question. So third question. How strong an earthquake will be if the big one strike? Okay, so how strong an earthquake will be if the big one strike? So when we talk about the big one, we are pertaining to the West Valley Fault. According to study, the West Valley Fault moves every 200 to 400 years, and the last record of the movement of West Valley Fault was about 350 years already. That is the reason why PBOX is constantly warning us about the possible movement of this plate. So the West Valley Fault transverse at the cities of Metro Manila, including Muntinlupa, Pasig, Marikina, Makati, Quezon City, and Taguig. It also transverse at some nearby provinces like Cavite, Bulacan, and Rizal, including Laguna. So when this West Valley Fault moves, we are expecting a 7.2 magnitude earthquake. This 7.2 magnitude earthquake will affect large infrastructure, will devastate infrastructure, including buildings, houses, and will cause large injuries to people. That is the reason why you should take every shake drill seriously, because earthquake strikes without any warning. So we don't know when will it strikes. We don't know when will this West Valley Fault move. So I am asking you to please take every shake drill seriously. Alright? So that is the reason why this convergence of plate is very important, because our country is very prone to earthquake, which is due to the collision to the movement of this different type of plate balance. So I hope that I have answered your questions, and some of the questions that were not entertained today will be answered by your by your subject teacher during the class discussion, on the class discussion tomorrow. Alright? So for your assignment, please answer page 31 of your science module. You are going to answer activity 1, week 4 activity 1. Okay? So this will be your assignment. This will be checked by your subject teacher during the class discussion. Now, if there are no more questions, so thank you for listening and have a good day.